Assalamualaikum and good day everyone. Today I will present about our group video. Our project title is Phantom LeakProtocol Secure Quarantine Zone Implementation. Our lecturer name is Dr. Jack Febrian Rusdi. Our group name is Underworld Gang and our group content of 5 members. Lim Chun Kai, in charge for the DHCP Server, Nur Qaisara Aqilah SOLEHAH, in charge for the web server, Ho Wai Loon, in charge for the SFTP Server, and NUR'IZZATI, in charge for the database server. Our team project, Phantom LeakProtocol, focused on building a highly secure, restricted quarantine zone using a server-client virtual architecture. As you can see on the slide, our Linux server VM acts as the central gateway. It uses dual adapters, an active for safe internet updates and an internal network adapter with a static IP to bridge to our isolated Linux client VM. To make this zone fully functional, the server hosts 4 critical services, DHCP, which lists IPs from .5 to .10, alongside local web, database, and secure SFTP services. Our testing proved that the client seamlessly accesses this local service but remains strictly blocked from the external internet, validating our secure isolation design.
Good day everyone, my name is Lim Chun Kai. Today I will explain network setup and DHCP server configuration for the operating system mini project. In this demo, I will show how the server and client are connected through an internal network and how the DHCP server automatically assign an IP address to the client. First, let's look at the virtual machine network setup. In figure 1, the server virtual machine use 2 network adapters. Adapter 1 is set to NAT for internet access and package installation. In figure 2, adapter 2 is set to internal network with the network name innet. In figure 3, the client virtual machine are also used an internal network with the same network name, which is innet. Next, I check the server internal IP address. In figure 4, using the command IP show EMPOS8, the server interface EMPOS8 has the IP address of 192.168.1.254. After that, I configure the DHCP server. In figure 5, I set the DHCP service to listen on interface ENP0S3 in the file. In figure 6, I configure the DHCP subnet and IP range in DHCP configuration file. The IP range is set from 192.168.1.5 to 192.168.12.10. Next, I restart the DHCP service and check the IT status. In figure 7, the service status shows that the DHCP server is active and runs successfully. Now I test the connection between the client and server. In figure, I ping the IP address 192.168.1.2554 and the ping is successful. This shows that the client can communicate with the server. Finally, I test the internet isolation. In figure 9, I try to ping Google DNS and result show 100% packet loss. This means that the client cannot access the external internet. In conclusion, the DHCP server was successfully configured on the server virtual machine. The client received an IP address automatically and was able to communicate with the server through the internet network while remaining isolated from the internet. That's all for me. Thank you.
Good evening, Dr. J. I'm Ho Wai Loon from S2G2. Today, I will present the secure SFTP server implementation on Debian Linux. First, we run the sudo apt update to refresh the local package repository cache and ensure we pull the lasting stable security patches. Next, we execute sudo apt install OpenServer-Y to install the SSH daemon. This natively handles SFTP, removing the need for high-risk legacy FTP daemon like vSFTPD. Then we use nano to modify the main SSH configuration file and SSH SSHD config, which as our central access control policies. So in the configuration file, we navigate to the port section and add the listen address 192.168.1.254 directly below. This explicitly binds the server to our internet interface, making it immune to external network probing. Further down, we verify the subsystem FTP Internet FTP using the built-in engine to optimize file transfer performance and simplify security management. Next, we create a new username researcher using user@m and set a password with passwd to use for our login test. After the password updates successfully, we run systemctl restart SSH to apply our rule. Run sslmp grep 22 to confirm the source cache standard. The service is listening exclusively on 192.168.1.254.22. On the client side, we initiate the connection using FFTP researcher at 192.168.1.254. After the ECDSA key handshake and password entry, we successfully accept the ensure FFTP prompt. Finally, we run put text.txt to stream a local file to the server. The transfer complete at 100% efficiently into the researcher home's directory, validating full functionality. So that's all for our SFTP setup and testing. Thank you.
Hi, Assalamualaikum. Today I will present the individual demo video for database server. My name is NUR'IZZATI binti Muhammad ZA'IM and I am from S2G2. For the configuration phase, step 1 is to install MariaDB. First, we run the command sudo apt update to refresh our package list, followed by sudo apt install mariadb-server-y to download and install the MariaDB server. Moving on to step 2, we secure the installation. We run the command sudo mysql_secure_installation to configure security settings, set the root password, and ensure the database server is safely set up for production use. In step 3, we configure the bind address by opening the configuration file with nano. We update the bind address to our specific IP, which is 192.168.1.254, so that the database can accept network connections. Then, in step 4, we run sudo systemctl restart MariaDB to apply the changes and restart the database service. Next, for step 5, we log into the MariaDB monitor as the root user using command sudo mysql-u root-p. Then, once inside, we create a new database named phantom_lake and switch to it using the command used so we can start creating tables. Then, we create a table named sensitive_data with columns for an auto-incrementing ID, the file name, and the upload timestamp. After that, we populate the table by inserting sample data like blueprint_v1.pdf and prototype_schema.docs into our table. Then, we create an internal user named internal_user that is restricted to our network subnet. Next, we grant this user all privileges on the phantom_lake database. Run flush privilege to immediately apply the changes, and finally exit the MariaDB monitor. Finally, in step 6, we verify the listening IP address. We run the command sudo ss-tlnp/grep:3306 to check our open ports. As shown in the output, the MariaDB service is successfully listening on our configured IP address and the default port 3306. Now, we move on to the testing procedure to test the connection from a client machine. We use the command mysql-h192.168.1.254-u internal_user-p to remotely connect to our server. Once successfully logged in, running show database confirm that we can successfully access the phantom_leak database from the client side. To finish the testing, we select our database using use phantom_leak and run a query to retrieve the data. By executing select all from sensitive_data, we can see that our samples row are successfully fetched by the client, proving the setup worked perfectly. Finally, we type exit to close the connection. And that's all from the database server. Thank you.
Hello and Assalamualaikum. Today I will explain about my individual demo for the operating system mini project. My task is the web server, so in this demo I will show how server and client communicate through the web server in the internet network. By the way, my name is Qaisara Aqilah SOLEHAH binti AZLEE. My metric number is B0325100713 and I am from BITS section 2 and group 2. So, after opening the terminal, we have to update the package list in Debian before installing Apache 2. It ensures the system download the latest available package version and dependency. Next, install the Apache 2 using code just like in the figure 1.1, which is sudo apt install Apache 2. It installs the web server package and required files so the server can host web pages. Second step, the file /etc/apache2/parts.conf is edited. Listen 192.168.1.254 port 80 is changed from listen port 80. This ensures Apache only listen on the internet network IP address instead of all interfaces. Third step, the file /etc/apache2/sites available/000 default.conf is edited. The default virtual host port 80 is changed to virtual host 192.168.1.254 port 80. This limits websites access to the internet network only. Fourth step, the file index.html is edited to create a simple web page. This web page acts as a proof that the client successfully connects to the web server. Fifth step, Apache service is restarted using the fourth code in figure 5.0, which is sudo system control restart Apache 2. Then, the last code in figure 5.0, which is sudo sstrnp grep port 80 is used to verify that Apache is listening on 192.168.1.254 port 80. Last step, from the client machine, the command in figure 6.0, which is curl http 192.168.1.254 is executed. The HTML content is displayed, so it proves the web server is working correctly and accessible through internet network. That's all from me. Thank you. In summary, all services were successfully configured and tested in the internet network environment, including the network setup, DHCP service, SFTP service, web server and database server. The client machine was able to communicate with the server correctly through the private network while maintaining network isolation from the internet. All required configurations and testing criteria were completed successfully. That's the end. Thank you for watching.